Hence, we have already started Fourier series, and there is one introduction class about Fourier series I have discussed earlier, and I have told you that we will discuss some mathematical tools that is needed for Fourier series, and the mathematical tools are like average value of a function, periodic function, and some special integral we have to know before discussing Fourier series, before going to more detail about Fourier series. Okay. So this class is basically the mathematical tools for Fourier series. Okay, and if you are new in this channel, then please subscribe my channel and go to the playlist, and you can see the topics on mathematical physics for IIT JAM. Two topics already we have completed. Two topics. One is for vector calculus, and another is single and multivariable calculus. Okay, and now we are in a Fourier series. So today basically I will discuss some mathematical tools like periodic functions, average value of a function, and some special integral, obviously. Okay, so let me discuss first about the periodic function. Okay, so what is actually mean by periodic function? You might have studied about this periodic function in your 10+2 level. Some basic idea about periodic function is needed to discuss about Fourier series. Okay, because any function is expanded in terms of Fourier series only if this function is periodic function. Okay, so function should have to be periodic first. Okay, and what is the property of periodic function? Any function f of x is said to be periodic if we add some constant with x, like f of x plus lambda, or in general you can say n lambda, where n is any integral value. Okay, so in this situation, if we have some function f of x, and if we add with x some lambda or some n lambda, then this function is said to be periodic function, where lambda is known as the fundamental period. Okay, here lambda is known as the fundamental period of this function. Fundamental period of this function. So to be periodic function, this relation must have to be hold. Okay, suppose for example we can give you an example. Suppose f of x is equal to sin x. This is the more popular periodic function. Suppose f of x is equal to sin x. Now if we add some constant with x, and the constant is obviously 2 pi. If we add 2 pi, then you will get sin x plus 2 pi, and you know that sin x plus 2 pi is also period is also sin x. Okay, so we can get the function again if we add 2 pi with this x. Okay, so f of x plus 2 pi is equal to f of x. So that means sin x is a periodic function because it holds this relation f of x is equal to f of x plus lambda, and here lambda is 2 pi. Okay, because you know if you put n here, n is equal to 1 here, then you will get x plus 2 pi. Otherwise, if you write it in this way also, f of x plus 4 pi, if you want to write, then you will get the same result. That will be sin x plus 4 pi, and that will also be sin x. Similarly, if you want to write f of x plus 6 pi, then also you will get the same result, that is sin x plus 6 pi, and that is also sin x. So you always will get f of x. Okay, because this is the multiple of 2 pi. Here is 2 pi, here is 2 into 2 pi. This means 2 into 2 pi, and this means 3 into 2 pi. Okay, so lambda is n is 1 here, n is 2 here, n is 3 here, and lambda is 2 pi. So lambda is called the fundamental period of this function. Okay, and all trigonometric function like sin x cos x, you should know about the period of all trigonometric function. Okay, so let me give you in listed form. Okay, so this is the basic idea about the periodic function, that any function, if we can write f of x as f of x plus n lambda, then lambda is the fundamental period. Now if you talk about the trigonometric function, okay, then you should know for trigonometric function the sin x and cos x have period 2 pi, always 2 pi. And if you talk about a mod function, all trigonometric mod function mod function like mod sin x, okay, mod cos x, mod tan x, all trigonometric mod functions have period pi. You can check one value that if you talk about sin x, then you know sin of x plus pi, this is mod sin of x plus pi is equal to minus sin x mod, and that will be sin x. So you can see this is nothing but your f of x plus pi, okay, and this is your f of x plus x. So you have the fundamental period is pi here, okay. So all trigonometric functions have period pi, and the sin x and cos x have period 2 pi, but you talk about tan x and cot x, they have period pi also, okay. So these things you have to remember always, because these will arise in terms of mathematics in Fourier series, okay. Always you need to know about this some fundamental thing about the periodic function. Now if suppose instead of sin x, okay, instead of sin x, if you have just sin mx kind of situation, suppose f of x is equal to sin mx, you can see in this case your period will be 2 pi by m, because you know if you add here f of x plus 2 pi by m, then only you will get this sin m into x plus 2 pi by m, okay, and from here you will get that will be sin mx plus 2 pi, and sin mx plus 2 pi is always sin mx, okay. So you can see here in this case your f of x, if f of x is equal to sin mx, okay, then your period, your fundamental period is 2 pi by m, okay. So you can conclude here an interesting thing that you have, if you have sin mx, then your sin x, okay, if you have sin x, then your period is 2 pi, but if you have sin mx, then your period will be 2 pi by m. So the coefficient of x is here in the denominator, okay. Here you have 1, so it will be 2 pi by 1. Here you have m, so it will be 2 pi by m. Suppose if you have sin 3x, then you will have the period will be 2 pi by 3. Similarly, if you have cos x, same result you will get, your period will be 2 pi. If you have suppose cos 5x, then your period will be 2 pi by 5. So this will arise here and there in Fourier series. And another thing, you know, if you change the variable, if you have f of x is equal to suppose sin t, okay, then also your period will be 2 pi. But if you have, sorry, this is f of t now, if you have f of t is equal to suppose sin 3t, then your period will be 2 pi by 3. And you know, if your function will be sin omega t instead of m, then you will get 2 pi by omega. And you might have familiar with this thing. This is the simple harmonic motion, displacement of simple harmonic motion sin omega t, and you know the period is 2 pi by omega, okay. So this is how you can find out the period of some trigonometric function, because always we need here in this chapter trigonometric function only. We don't need to discuss about more details on periodic function, that is the topics of your 10+2 level mathematics. But here we just need these kinds of function and the period of them, okay. But sometimes you maybe you have to knowledge about some addition or subtraction of this function. If there is a combination of function, okay, then sometimes you need to know how to find out period also. So moreover, if you have the combination of two functions, suppose you have a periodic function f of x and another periodic function is g of x, okay. Suppose the period of f of x is t1 and the period of g of x is t2. In that case, if you want to find out the period of the combination of these two functions, suppose f of x plus g of x, or if you have f of x plus suppose f of x into g of x, or you sometimes need to know about f of x minus g of x, or f of x divided by g of x. These kinds of situation may also be arise, okay. But if there is a function, suppose the function is h of x, and the function is linear combination of fx and gx. Suppose there is a function h of x, and which is nothing but the linear combination of f of x and g of x, the a f of x plus g f of x, b into gx, okay. This is the linear combination of fx and gx, which is equal to h of x. Now if f of x and g of x are periodic function with same period, if f of x and g of x are the periodic function with same period, then h of x will also be periodic function with the same period. Suppose the period of f of x and g of x is same, suppose t. In that case, what we have a into f of x plus t, we can write instead of f of x, plus b into g x plus t. And now in that case, if you write it as h of x plus t, x plus t, then you will get here this f of x plus t is again f of x, and g of x plus t again g of x. So this is nothing but h of x. So you can prove very easily that h of x plus t is equal to h of x. H of x. Okay, so this is how you can find out that if the two functions have the same period, okay, then if you take the linear combination of these two and construct a new function, then that new function should be periodic function with same period. But if the function have different period, then if you take their linear combination or multiplication, or if you divide one function with that other, then your period will be always LCM of T1, T2. So this will be the rule you need to know about. Okay, if the periods are different, then any combination like this, plus minus or multiplication or division, then your period will be LCM of T1 and T2. Okay, but it can only be hold, these rules will only be hold if their combination is periodic function. If their combination is not periodic function, a periodic function, then obviously the rule will not be hold. But I am not going to that detail because you don't need this kind of thing. Okay, we only need here up to this. Sometimes you have to know these things also, but this will arise in very rare case. Okay, so let me give you an example to understand this thing also, that if you take that linear combination of these two different periodic function, suppose if you have a function like f of x is equal to, suppose you have sine, suppose 3t as 3x plus sine 5x, suppose you have this kinds of situation, then what will be your period of f of x? Here the period of this function is 2 pi by 3 and period of this function is 2 pi by 5. So what will be the period of f of x? The period of f of x will be, in that case, period of f of x will be just LCM of 2 pi by 3 and 2 pi by 5. Okay, so what will be the LCM? So LCM will be the LCM of 2 pi and 2 pi is what? 2 pi and 2 pi. The LCM of 2 pi, LCM, this is equal to LCM of 2 pi and 2 pi and divided by HCF of 3 and 5. And you know the LCM of this is nothing but 2 pi and the HCF of this is 1. So the period of this function is just 2 pi. Okay, so this is how you can solve these kinds of situations also. Okay, if there is a combination of these functions or there is a multiplication, division, etc., then you can find out the period of this function, the new function, period of this new function you can calculate by using this process. Okay, so this is a very easy way to understand. Okay, and this is one mathematical tools that we need to know on Fourier series, and another is very important, that is the average value of function, and corresponding to this average value of function I like to discuss about some important integration value also. Okay, that will arise here and there in Fourier series. So let me now discuss about the average value of a function. Okay, so now let me discuss about the average value of a function. Okay, you might have studied about the average value of some numbers. Okay, and the average value of some numbers will be just, if you want to find out the average value of some numbers, then what you have to do, just you add the numbers and divide it by the number of numbers. Suppose if you want to find out the average value of the numbers from 1 to 100, then what you have to do, just you add this numbers dot 100 divided by total number of numbers, that is 100. So this is the average value of some numbers. Okay, so this is a very easy process, but here I want to know about want to find out about the average value of a function, suppose we have a function like this. This is the f of x and this is x. Okay, so suppose we have a function something like this. Okay, and we have to find out the average value between this interval a and b. So we have to find out the average value of the function in this interval, and the functional value is f of x. Now if you divide here from a to b, suppose this is the point x1, okay, and this is the point xn, okay, and there are various terms x2, x3, and here the functional value is f x1, here the functional value is f x2, here the functional value is f x3, and here the functional value is f xn. So if you want to use this method, then what you will do, you will just do and the total interval, let me take it is n number of interval is there, x1, x2, x3 dot xn. So total number is n. If you want to compare this, if you want to compare the average value of function with this, then what you should write? You should write like this: f of x1 plus f of x2 plus dot f of xn, okay, divided by n. But this is not the actual average of this function, because you cannot take all the values from this point to this point, all the functional value from this point to this point. Okay, so this is just an approximation, you can say, but this is not a very good approximation. But if you want to find out the average value with this interval with some good approximation, then what you have to do? You have to just multiply with this at delta x, okay, at delta x in denominator and the numerator. If you multiply with this delta x, and delta x is what? Delta x is here actually the interval. Okay, suppose if you want to take there are n number of intervals, then this is actually n into delta x, okay. So each interval is delta x. So if there is n number of x1, x2, x3, n number of points, then n into delta x will be just b minus a, and it will follow exactly n into delta x is equal to b minus a. If n tends to infinity, then all the points you can actually from here to here, if you take n tends to infinity, then it will automatically carry each and every point on this curve. Okay, so if you want to convert this as a average value of this function within this interval, then what you have to put? You have to put just n tends to infinity, okay, and delta x tends to 0, and and in this situation this n into delta x will give you the exact value of b minus a, okay, and your numerator will be the integration of f of x dx. Okay, if you extend these points up to infinity, then these points will be, this functional value will be continuous. Okay, and in that case your this will convert it into something like this: integration f of x dx, and this is n into delta x is now your b minus a, and the limit of this integration is a to b, and this is now the exact average value of this function f of x. Okay, so you can write for any function within certain interval the average value of any function, and this is very useful result. It will be used here and there in physics. Okay, so your average value of any function, you can write it in this way: f of x average, or you can write in this way also: f of x average will be nothing but a to b f of x dx divided by b minus a. Okay, so this is your average value of a particular function f of x within a certain interval b minus a. Okay, now if you want to find out some well known average value of some trigonometric function like sin x, cos x, okay, if you want to find out the average value of sin x within the full period, cos x within the full period, okay, or sin square x, okay, cos square x, then you can use this integral, and this result will be very important in this chapter, Fourier series. These results will be used here and there, okay, in this chapter. So let me find out the average value of this function, and the average value of sin x and cos x in the full period will always be 0. Please remember this thing. If you want to find out with this integration, you can do it. If you want to find out that what is the period of this sin x, the period of this sin x is 2 pi and cos x is also 2 pi. So if you want to find out the average value of sin x, okay, average value of sin x, then it will be just integration 0 to 2 pi sin x dx divided by 2 pi minus 0, b minus a, and it will always be 0 because the integration 0 to 2 pi sin x dx is 0. Similarly, if you want to find out the cos x, or not only cos x, if you want to find sin 3x, sin 5x, sin mx within each period, then the period will be 2 pi by 3. So in general, actually the sin or cos, the average value of sin or cos within the full period will always be 0, and you can easily predict this result by using the graph. Okay, so if you know about the f of x versus x graph for sin x, then you know the graph will be something like this. Okay, and you can see from here to here 0 to 2 pi, this area and this area will be same and these are opposite to each other. Okay, so if you add these two area, you will get always 0 because this is the upper half area and this is the lower half of the x-axis. So if you add these two, you will always get 0, and that's why its average value is obviously 0. But if you want to find out the average value of sin square x and cos square x, then this is something different, because the sin square x and cos square, what is the period of sin square x and cos square x? If you again draw the graph of sin square x, then the graph will be something like this. Okay, so this point is actually 0, and this is again pi, this is 2 pi, this is 3 pi, and if you extend in this region, then you will get here minus pi also. Okay, so you can see the period of this function is just pi. The function is repeating after the value of pi. Okay, so its period is pi. So if you want to find out the average value of this function, and another thing you can see, if you draw the graph of cos square x, if you want to draw this is sin x versus sin square x versus x, actually sin square x versus x, and if you want to draw the graph of cos square x versus x, then what you will get? You will get this kinds of situation. Okay, this kinds of situation you will get. So here this is 0, this is pi by 2, okay, and this is minus pi by 2, you can see. Okay, minus pi by 2, and the period is pi, minus pi by 2, and this is 3 pi by 2, okay, so this is same. So, and you can see here that cos 90 is 0, cos square pi by 2 will be also 0. So the graph of cos square x versus x is this, and the graph of sin square x versus x is this. But if you compare these two graphs is actually same. Maybe its points are different, but the graphs are looking same. Just if you shift the origin, then it will be same. If you want to see this graph within this interval minus pi to plus pi, and if you just shift this cos square x, this axis here, then you can say within this interval the graph is same. You can see minus pi by 2 to 3 pi by 2. Okay, because this interval is minus pi by 2 plus pi is pi, and this interval is 0 to pi is pi, same. If you talk about minus pi by 2 to 3 pi by 2, you will get minus pi by 2 plus 3 pi by 2, then this is nothing but 2 pi by 2, that is pi. Okay, and you can see if you minus pi by 2 to 3 pi by 2, sorry, minus pi by 2 to 3 pi by 2, so this is 3 pi by 2 plus pi by 2. Okay, so it will be, this is the negative, so the amount of this value is minus pi by 2 plus 3 pi by 2, so it will be just 4 pi by 2, so it will be 2 pi. And similarly you can see here it's minus pi to pi, this is also 2 pi, this is also 2 pi. That means the average value of these two functions will be same. If you find out the average value within this period minus pi to plus pi, or within this period, that will imply same thing. Okay, so the average value of minus pi to pi sin square x, you can say the area. Okay, the area, this is minus pi to pi. Okay, sin square x dx is nothing but the area of these two peak. Similarly, if you find out that the area of this region will be same as this. Okay, so if you want to find out the integration of minus pi to pi sin square x dx, and this will be same as minus pi to pi cos square x dx, this will be same, because this is nothing but the area under the curve. Okay, so these two will be same. So instead of doing this kinds of integration, you can find out the result of this integration minus pi to pi sin square x or minus pi to pi cos square x dx by using this concept, that the area under this curve and the area under this curve is same, and its interval is same. So it does not matter you are writing minus pi to plus pi, or you are writing minus pi by 2 to 3 pi by 2. So it does not matter, because the result is same, the area under the curve is same. Okay, so we can easily write that minus pi to pi sin square x dx is nothing but equal to the minus pi to pi cos square x dx. Okay, now if you want to find out this integration, that if you add this to integration, then what you will get? You will get just minus pi to plus pi sin square x plus cos square x dx plus cos square x dx is equal to what? You will get this sin square x plus cos square x dx. So let me find out. So what will be this? So this will be just minus pi to plus pi, then sin square x plus cos square x is just 1. So it will be 1 into dx. Okay, so this will just integration of dx is x, and the limit will be minus pi to plus pi. So it will be just 2 pi. So if you add this to integration, then you will get 2 pi. So each integration will give you the result only pi. This is the obvious thing. So you will get pi obviously. So minus pi to pi sin square x dx and minus pi to pi cos square x dx, you will get pi. So what will be your average value? You can find out the average value of sin square x is nothing but integration in the interval minus pi to plus pi. So it will be just minus pi to plus pi sin square x dx divided by pi minus of minus pi, b minus a, and this integration is giving pi, and this pi plus pi is 2 pi. So you will get always half. Okay, so the average value of sin square x and the cos square x within the full period cos square x, you will get just half. But this is not the fundamental period for sin square x and cos square x. This is not the fundamental period of sin square x cos square x, because the graph of the sin square x and cos square x is something like this. So this is the period 0 to pi. This is the period. So pi is the fundamental period, not 2 pi. But this function is repeating in this region also. So this is not the fundamental period, but this is one of the period also, because n lambda is the period. So here n is 2 pi is the period. So the result will be same. If you want to find out the average value of this function within this interval, then also you will get the same result. If you want to find out the average value of sin square x in this interval, that is integration 0 to pi, okay, 0 to pi sin square x dx divided by pi minus 0. If you want to find out this integration, if you solve this integration, then also you will get half, the same result, because the average value will not be changed. Okay, if you want to find out the average value within the limit minus 2 pi to plus 2 pi, then also you will get the same result. So it need not to be the fundamental period. Obviously, if you want to find out the average value within this fundamental period 0 to pi, then we will get the result half. But if you calculate the average value on the multiple of this, on the interval multiple of this fundamental period, then also you will get the same result. you will get the same result. Okay, so this is how you can remember and you can predict the result by using the graph instead of solve the integration conventionally. Okay, so this is all about the average value of the function. And now I want to give you a list of these kinds of integration that we will use in Fourier series. Okay, so please note down this integration, that always you have within the full period. Okay, so within full period, if you have just integration minus pi to plus pi, sin x, or you can say sin mx. Okay, sin mx or equal to minus pi to plus pi cos mx, this will always be 0. Okay, this will always be 0. And if you talk about minus pi to plus pi sin square mx is equal to minus pi to plus pi cos square mx or nx, you can say mx or nx, whatever you can write, will be equal to just what? That will be just the average value will be pi. The value will be pi, but the average value will be half. Okay, and this value will be pi, because individually if you add these two, you will get 2 pi. So each will give you 5. And if you divide by 2 pi, then you will get half. So if you want to find out the average value, then there will be half. In that case, you have this kinds of situation, 1 upon 2 pi. So let me write on this also. If you write this in this way, sin square mx is equal to 1 by 2 pi minus pi to plus pi cos square mx, then you will get just half. So this is the average value, but otherwise you will get pi. Okay, so please remember this thing. Hello. Okay, and if you have multiplication of these two, suppose if you have multiplication of these two, suppose you have minus pi to plus pi sin mx cos nx dx, or if you have minus pi to plus pi sin mx sin nx, or if you have minus pi to plus pi cos mx sin nx, cos mx cos nx. Okay, or if you have if you have sin mx cos nx, then in this case you will get 0 always. But if you have this kinds of situation, sin mx sin nx or cos mx cos nx, then you will get 2 kinds of result, because you know if you have m and n are unequal, then you will get this kinds of thing. So you will get result, you will get 0 result. If you have m and n are different, then this is sin a sin b, this is cos a cos b, and if you expand by using the trigonometric formula, then you will get m plus n or m minus n, something like that. That will be like this. So these results will be 0, but this result will always be 0, either m is equal to n or m not equal to n. This if these are different, sin mx and cos nx, then this will give you always 0 result. Okay, because this is different, sin and cos, so this will never be like this, sin square or cos square. But this, if n is equal to m, you will get sin square here. If m is equal to n, you will get cos square here. So that will be similar to this kinds of situation. Okay, so you will get this is equal to pi also if m equal to n. You will get 0 if m not equal to n. If m not equal to n. But here you will get 0 always you will get 0, because you always get this kinds of result, m plus n or m minus n. So this is something like sin kx type or cos kx type. If you take m plus n is equal to k or m minus n is equal to k, so this will give you always 0 result, either m is equal to n or m not equal to n, doesn't matter. But this result will get 0 if m not equal to n, then only you will get this kinds of result, m plus n or m minus n. That will be something like sin mx or cos mx, because sin m plus nx or sin mx will give you the same result, because m plus n will be another integer value. Obviously this m n or integer value. Okay, So so this will be always 0, but here you can see if m is equal to n, then this will be something like this. So you will get the pi, and otherwise you will get 0 result. So this integration will be used always, and if there is 1 by 2 pi here, then you will get half here, but 0 will be 0 always. Okay, and another important integration formula we need to know here, that is the integration by parts, and that is the UV formula. We will use this formula here, integration by parts, integration by parts UV formula, that is integration UV into dx, and u and v are the function of x obviously. So in this situation, this can be written like this, that u into v1, v1 means the integration. Okay, so first function is unchanged, and second integration of second function, minus you will get derivative of first function and again integration of second function. v2 means the integration of v1. Okay, and the signs will be alternative. Okay, and next you will get u double dash and v3, and then you will get again u triple dash and v4 dot dot. You will get this kinds of thing. So this is the successive integration formula. Let me take one example that you will get easily. If you have just x square sin nx, sin mx, or this kinds of situation we will get in our analysis of Fourier series. So we can take this as first function and this is second function. So this is the first function. So according to this formula, this x square will be unchanged and integration will be this. And integration of sin mx is nothing but minus cos mx by m. So this is now v1. This is now v1. So in the second step, what you have to do, you have to take the differentiation of this. This is 2x, and integration of this now. Integration of this. So what will be the integration of cos mx is sin mx. So it will be just minus sin mx divided by m square. Okay. Now what you have to do, you have to move to this point. Okay. So u double dash means now you have to take the differentiation of this. So this will be just plus differentiation of 2x is 2, and integration of this will be what? This will be again minus plus, it will be cos mx divided by m cube. Okay, now you will get 0 because this term, if you differentiation this term again, you will get 0 into something. So you have to do this process repeatedly. Okay, and you have to stop when you will get the 0 result. So it will depend on this first term. So you have to choose carefully, very carefully about your first function, and you have to choose this first function in such a way that after some successive differentiation, it should be 0. Here you can see first term is x square, second term is 2x, then 2, then 0. So when it will be 0, so your work will be finished. So this result will be very simple, it will be minus x square cos mx by m plus it will be 2x sin mx by m square plus 2 cos mx by m cube. So this is your result of this integration. And if you have limit like this, minus pi to plus pi, then you have to put the limit here. Okay, so we will do this kinds of integration in our further topics in analysis part. Okay, so this is all about some fundamental mathematical tools that we are going to use in the next class, from the next class, and we will use this integration, and we will find out the Fourier constant and something like that. We will discuss in the next class. But moreover, overall, this is your main fundamental mathematical concept or mathematical tool that you need here, that I have discussed in this class. Okay, thank you.